Let's go on the topic center of mass. Topic is center of mass. Center of mass. Okay. This topic is center of mass. Okay. For a system of n particles. For a system of n particles. How many particles? N particles. There is one point for the system where entire mass of the system can be assumed to be concentrated. Okay. If all the external forces are assumed to act on this point, its motion is similar to that of the system upon which the same external force is acting. Okay. The point is called the center of mass of the system. The point is called the center of the mass of the system. The point is called the center of the mass of the system. Okay. Point, its motion is similar to that its motion is similar to that of the system upon which the same external force is acting. The same external force is acting. Okay. The point is called the center of mass of the system. The point is called the center of mass of the system. Okay. System. Suppose we have a system of total mass capital M. Suppose we have a system of total mass capital M. Okay. Total mass of system. Okay. And n particles are mass points of masses m1, m2, m3, mn. N is the number of particles. Okay. And m1, m2, mi, ml. Okay. The position vector are respectively the mass m1, m2, m3, mn, whose position vectors are represented by r1 vector, r2 vector, r3 vector, rn vector respectively. Then the center of mass of the system is defined as the point whose position vector capital R is given by capital vector R equal to m1 r1 vector plus m2 r2 vector plus m3 r3 vector plus plus mi ri vector plus plus mn rn vector whole upon m1 plus m2 plus plus mi plus plus mn. Okay. Now let's sigma mi ri vector equal to sigma mi. Okay. This is sigma mi ri vector upon capital M as sigma mi equal to capital M, the total mass of the system. If the center of the mass coincides with the origin of the system, then vector r equal to 0. Vector r equal to 0 because center of mass coincide with center of mass coincides with the origin of the system, with the origin of the system, okay, origin of the system. So vector r equal to 0 and r equal to 0 vector and sigma mi vector equal to 0 vector, okay, 0 vector, okay. The center of mass is thus defined. The center of mass thus defined as a point in space, defined as a point in space, such that the vector sum of the moment of the mass points around it is 0. Points around it is 0. It is 0, okay. Velocity of center of mass. Next is velocity of center of mass, okay. Let us consider the motion of the system considering of n particles and total mass capital M, assuming that the mass of the system remains constant, no mass enters or leaves the system. So mr vector equal to sigma mi vector equal to m1 r1 vector plus m2 r2 vector plus plus mi vector plus mn r n vector, okay, mn r n vector, okay. Then differentiating with respect to time, we get differentiating with respect to time. Differentiate with respect to time, we get capital M d vector r upon dt equal to MIDR1 upon dt plus M2 M1 dr1 upon dt plus M2 dr2 upon dt plus plus MIDRI vector upon dt plus plus MN dr n upon dt vector, okay. But dr vector upon dt equal to capital V vector, the velocity of the center of mass. The velocity of the center of the mass, okay. Because this is represent the distance, so distance upon time equal to displacement upon time equal to velocity, okay, and dr1 vector upon dt equal to v1 vector, comma dr2 vector upon dt equal to v2 vector, comma dri vector upon dt equal to vi vector, comma drn upon dt vector equal to vn vector, okay. So this is this is mv, this is capital M into V, capital M into V equal to m1 v1 vector plus m2 v2 vector plus plus mi vi vector plus plus man vn vector, okay, equal to sigma mi vi vector. This is equation number 1, okay. The velocity of center of mass is given by capital V equal to m1 v1 vector plus m2 v2 vector plus plus mi vi vector plus plus man vn vector whole upon capital M, and dividing both sides by capital N, then this value capital M and capital M is cancel out to capital M, okay. So this value is changes in sigma mi vi vector upon capital M. This is the equation number 2, okay. From relation first, we also find the vector sum of the linear momenta. Vector sum of the linear momenta of the individual particles of the individual particles is that the total linear momentum of the system is that the total linear momentum of the system is equal to the product of the total mass is equal to the product of total mass of the system and the velocity of the center of mass, and the velocity of center of mass, okay. From the relation first, vector sum of the linear momenta of the individual particles is that the total linear momentum of the system is equal to the product of total mass of the system and the velocity of the center of the mass, okay. In the absence of any external force, the total linear momentum of the system P is conserved. P is conserved. So capital M into vector V equal to sigma MIVI vector equal to vector P equal to a constant, okay, and vectors R vector V equal to a constant vector, okay. Hence the velocity of the center of mass hence the velocity of the center of mass of a system remains constant, if no external force is applied to it. If no external force is applied to it, okay. Acceleration, and next is acceleration of center of mass. One minute. Acceleration. Differentiating equation number first with respect to time t. Differentiating equation number first with respect to time t, okay. Time t, we have capital M d capital V upon dt vector equal to m1 d v1 vector upon dt plus m2 d v2 vector upon dt plus plus mi d vi vector upon dt plus plus mn d vn vector upon dt. So capital M vector A equal to m1 a1 vector, this is vector, okay, and this is acceleration, m1 acceleration a1 vector plus m2 acceleration a2 vector plus plus mi acceleration I vector plus plus mn acceleration an vector, where a is the acceleration of the center of the mass, where vector a is the acceleration, where a is the acceleration of the center of the mass of the center of the mass, okay. And A1, A2, etc. are the acceleration of the individual particle, okay. The acceleration of the center of the mass is given by vector A equal to m1 a1 vector plus m2 a2 vector plus mi ai vector plus mn an vector whole upon capital M. This is the equation number 3. Okay. According to Newton's second law of motion, according to Newton's second law of motion, according to Newton's second law of motion, m into a vector equal to vector f, equal to vector f. Okay. The external force acting on different particle is capital M into a vector equal to F1 vector plus F2 vector plus Fn vector, Fi vector plus Fn vector. Okay. Total is capital Fn vector. Okay. Capital Fn vector. Okay. This is the external force acting on different particles. Okay. Thus the product of the total mass of a system, thus the product of the total mass of a system, of the total mass of the system and the vector acceleration of the center of mass and the vector acceleration of the center of mass is equal to the vector sum of all the external forces acting on the individual particles, individual particles of the systems, who no external force is acting, then F1 vector plus F2 vectors plus plus Fn vector equal to sigma Fi vector equal to 0, because when no external force is acting. Okay. Or acceleration vector A equal to 0 vector. That means, hence in the absence of an external force, hence in the absence of an external force, the acceleration of the center of mass, the acceleration of the center of mass is zero, and therefore the velocity is a constant vector, and therefore the velocity is a constant vector, Okay. Good, thank you. Next heading is total linear momentum about the center of mass.